markets closed Friday and Monday. This is how they've opened today. You see a pound there. You can say buying you $1.26. Back up slightly.
Now, we all rely on medicines at one time or another, whether it's to deal with an irritating cough or to tackle something more serious.
Yeah, that's why medical innovation is so important. Our lives could quite literally depend on it. Well, our next guest is using artificial intelligence to push back the boundaries of medical science.
His company, Benevolent AI, deploys a powerful computer to sift through masses of data at the blink of an eye. The company says the computer makes connections and discoveries it would take scientists many lifetimes to come up with.
Well, the company was formed in the UK back in 2013. Since then, it's expanded pretty rapidly. In fact, it's now the largest artificial intelligence company in Europe.
It's struck license agreements with some of the world's biggest pharmaceutical companies. Benevolent AI is working on more effective treatments for diseases like Parkinson's and Alzheimer's. Maybe it can fix the fact that I can't speak very well this morning.
We did all the help we needed. Well, with us is Mulvany. He's the co-founder and director of Benevolent AI. Nice to see you. Good morning. Pretty comprehensive run through there of sort of what you do, but I'm interested in hearing it from yourselves. I mean, how do you describe this to people? If someone says, what do you do? How do you describe it?
Okay, so you can imagine that an awful lot of research has gone into understanding the human body and how it works. So there's lots of knowns. There's lots of things that we've determined along the way. But yet there's lots of unknowns that are out there. And what our system is able to do, it takes all of the things that are known and it says, or it deduces that this should be known based on what is already known. And one way that I like to describe it to people, you may remember back in your kind of old chemistry classes that you had the periodic table of elements. But years ago, there were big pieces of that periodic table that were missing. You had characteristics that you knew. You knew that, for instance, the atomic number, how many electrons it was going to have. Just the element itself had never been found. And that's what our system does. It finds things that should be known based on what is already known.
So it's mixing computer science, maths, medicine, the whole lot, to sort of try and come up with solutions to things like Alzheimer's, multiple sclerosis, neurological diseases. So where are we with that? I mean, it sounds fantastic, but when will we see the results?
So we have 22 programs that are in development. Two of them we've licensed away to a big pharmaceutical company in the United States. The remaining we're developing. Our most advanced is in phase 2B to treat disease. So we're feeling pretty confident with our progress to date. And in terms of the speed with which it took us to get there, it's far more condensed. My last company was a biotech, so I have some.
And when he says his last company, he's kind of created and sold 11. Is that correct?
Yeah, that's correct.
At 48 years old, he's a bit of an overachiever in the studio here.
And also on that point, I mean, the business you've got now valued at over £1 billion, which is, it becomes one of the tech unicorns, as they're often called. Is that a help or a hindrance when it comes to, telling people what you do? Do they say, oh, look, you're fine, you're worth this already, you don't need any of our help?
Well, one of the nice things about working in the industry as it relates to medicine, we don't have to rely on any type of technology to kind of demonstrate our success. It's so highly regulated. The European regulators, the FDA, require us to prove our biology over and over and over again, to prove our toxicology over and over to ensure that it's safe. The results become somewhat self-evident, so we don't have to rely on tech buzz. The things that pharmaceutical companies understand is the underlying drug product, rather than how you get there.
But when it comes to the AI, will the big pharmas be trying to do this themselves as well? Is this going to become a part of the normal process in finding new cures for diseases in the future?
It should do, and it's important that it does do. In fact, if you imagine, the amount of new information that's created every day, and in life sciences alone, there's 10,000 new journal publications every day. It's impossible for any scientist, any group of scientists to just